Hi guys, in this lesson I will explain how to delete rows and columns from the data frame with the help of the drop method. Let's first create a new file and call it drop. Then I will import my pandas library as usual. Import pandas spd, and I will try to pick up one of these files which is located inside of the data folder nbcsv and import it to my Jupyter notebook by typing the pd read csv, two dots, one step back, data folder, the name of the file, and again print out the first 5 rows of this data frame. Okay, we have successfully imported our data. Now if I want to check how many rows and columns there are in our dataset, we could see that we have 463 rows and 9 columns here. Let's say that I want to drop the first 2 rows in our data frame, like the first and the second rows, but actually this row starts from 0, that's why it will be the second and third rows of our data frame, but I will call it by index. I want to drop out these first and second rows. In order to drop them, I will type in the df drop method, then open the scopes, and inside of the square brackets I will type in 1 and 2 because I want to drop these integer values here, and then these are the indexes of our data frame. That pandas just automatically defines these indexes to our data frame here, and then I can click shift enter and it will drop the first and second rows of this data frame. But by default it has, we already know, it has the axis equals by 0 because 0 is related to these rows, index rows here, while 1 is corresponds to the columns, but by default it has a 0. And if I click shift enter, you could see the result is the same. But just keep in mind that each time when we are just refreshing or running this line again and again, it just prints out the same result, because it just refreshes the data and again finds these first and second rows and just deletes it again. But if I try to just in place it to true, I will make it permanent or save it with this parameter, and after running it first time and run it again like this one, it will print out the error because these rows are not existing yet, because we have deleted it and saved it to the data frame. If I just call it here, run it, you could see these first and second rows are not existing. But without in place true parameter, if I just delete this one and run it, first I will just refresh the data and run again this one, you could see it has dropped it. But if I call it here df, it just recovered these rows, but with in place true parameter here, it will save it and print out skip these rows first and second because they have been deleted, and print out the third row here. But what if I want to set an index here, the string index, and delete these rows based on the set index here? Let's see that I want to set this team index to my data frame. I will type in the df set index, and then I will type in the team, and make it permanent, like in place equals true here, and click shift enter, call the data frame again. You could see that we have defined this team column as an index here. But what if I want to delete the rows based on the index value here? Let's see that I want to delete all the rows with the Boston Celtics and this value, Utah Jazz value. In order to do this, I will type in again the drop. The syntax is the same. By typing drop, open the round brackets and type in inside of the square brackets, I will type in the values. Which value do you want to delete? This value and this one, right? we could define 1 or second and as many parameters or values as we want here. And then I will have to do what? Save it by typing the in place equals true parameter. Click Shift Enter, call the data frame again, and you can see here's the difference. It has removed all the rows which contains this value here, Boston Celtics and this Utah Jazz. You could see this data frame is different from this one because it has removed all these values here. But what about integer values when you have defined integer values as index? Let's just, before defining the integer values, I will check the data types. And you can see we have the object float. None of these values have integer data type here. But if we want to just define the integer value, let's first define the float value. And in case of the integer value, we'll just make a bit, we will just explain it. Okay, first I will try to set this number as an index here. This number has the floating data type, right? Yes, but I will convert it later for the just practical purposes. I will type in the df set index number, right? I will set the number as an index and type in the in place equals true and call the data frame here, like data frame. You will see we have defined this number with floating data type as an index here. But what if I want to drop based on this value? The syntax, of course, is the same. We will first, before dropping, we could even sort it by typing the df sort index method. If you remember it, we have covered it again. You could see it just sorts it from ascending order here. And now if I want to drop them, I will type in the df drop, and this is considered as a 0 here, in spite of the fact that it has a float data type. It's 0 here. If I want to drop the 0, we will not just surround it or paste it inside of the these quotes. We will just type in the 0 because it's almost the integer value, float value, and then type in the in place equals true. Click Shift Enter and call the data frame again. You can see it has dropped all the rows with this 0 index label here. But if you are worried about the float structure, first you should reset it or refresh the data frame. If you want to remove these points here, you should convert first to the integer and then remove it. Let's just do it again. I will not reset it, I will just refresh it in order to make it simple for you to understand, and call it again. You could see we have called this data frame again, and we have this number with the floating data type. Before converting or before deleting setting this number as an index, we should first convert it to the integer by typing the df number equals df number. Then I will do what? Type in astype int. Click Shift Enter. We will try to convert this number to the floating because of these strange decimal points here. This is just the demonstration of proper way of removing the index labels. Okay, we have printed, we have an error here. Why it says that we can't convert these integer values? Okay, we might have what? The missing values inside of this column. That's why we should first do what? We should first drop these missing values by typing the df drop now, and then equals in place equals true. We will try to drop it and then call it. We could call it here. You could see it has maybe converted it. If I check the data type again of these all columns and check the number here, you could see it has converted the number to the integer here. And now we could even see this. You could see the numbers has cleaned off from these decimal points. And again, we could do what? Set this number as the index here. Again, set this number as index right now. Index, you could see it has set it. And then we could do what? Remove this one by typing the df drop. Again, you could see the result is the same. We have just removed these decimal points just because of convenience here. And now what about columns? Let's try to drop columns. In order to drop columns, again the syntax is almost the same. We will type the df drop, and if we want to drop specific columns, we will take in the theme height, for example, these two columns here. I will type in the df theme first, then I can add to the list the second one, height. We could even drop one column, that's not a problem inside of the list. I think we could easily do it. You could see df theme. What's the problem? Okay, we haven't defined the column here, not found in the axis. We should define the axis here. Equals axis equals to 1. You could see theme is not existing yet, but we haven't saved it here. If I just call it again, you could see theme is existing in this data frame. We should save it before after deleting if you want to get rid completely of these columns. In order to do that, we can easily type in the in place equals true parameter and add in even one more column here, like height, right? Okay, we have defined axis equals to columns, in place equals true, and remove this one. Click Shift Enter, call the data frame again. You could see it has dropped 2 columns here. And we could even assign it in a different way. We already don't have these columns here. I will pick up one more column in order to demonstrate in another way, like position. I want to drop the position. In order to drop it, I will type in the columns. This is another syntax, and delete this. Even we could save it. Now it does not matter. We're just, let's try to delete it and click Shift Enter and call it again. You could see it has dropped position column, but with axis equals to 1, I will again pick up one column here and try to delete H2. Click run it again. It works perfectly okay. You could see how many options do we have. If we want to drop again, we even have one more option here. Instead of the columns, we could type in the labels equals to, let's try to pick up one more column here, because we are just saving this data frame again and again, and we eliminate the number of columns here. Weight axis equals 1 and call the data frame again. You can see we have already deleted this weight column with the help of these labels argument or keyword here. We could even use the Python del function to drop the column. We should all that we should do is type in the del and the name of the column inside of the data frame. Let's see that I want to delete this name here, name column. I will type in the function Python and del with this data frame column and call the data frame again. You can see it has removed the name column here. Okay, I think that that's it for now. Thank you for watching this video. Subscribe to my channel. Have a good day. Bye.